Imagine flipping a switch and watching a tiny orange bead appear out of nowhere on a copper wire, like a seed sprouting, while bubbles race up the solution. On a black bench, a beaker of blue copper sulfate cradles an orange anode on the left and a copper cathode on the right. What's happening next? Now the camera stays fixed, letting us see the blue solution filling 2/3 of the glass. The orange anode catches the light on the left, while the copper cathode stands upright on the right, a ruler beside it marking millimeter. It's like watching a sapling emerge from a pod, and surprise is about to sprout. Zoom in, and you see the cathode tip catching a faint orange glow, as if a bud were unfurling underwater. An unseen hand points directly at the spot, highlighting how metal seems to materialize from the clear liquid. You might wonder what fuels this sudden growth. Let's watch it stretch further. The faint orange filament now pushes upward, curling like a newborn seedling reaching for light. Each inch it gains catches the bench glow, turning the clear solution into a backdrop for this living metal. You can almost hear the quiet question, how does a solid strand appear from nothing? And it keeps climbing. Shift focus to the anode. Its once shiny orange surface now looks dull, pitted, as if tiny bites have been taken out of it. The surrounding blue water lightens, a visual cue that something is leaving the solution. Meanwhile, the filament at the cathode tip still sparkles, begging more growth. What will the copper tree become? Now the filament has swelled into a solid orange rod, roughly a centimeter long, standing proud in the glass. Tiny bubbles still drift upward from the anode, a subtle reminder that the reaction continues. The solution deepens to a richer green, framing the growing metal like a garden stem. Will it keep branching outward? From the sturdy rod, fresh offshoots burst forth, each snapping out at sharp angles like tiny twigs on a miniature tree. The orange glow multiplies, bathing the glass in a warm light, while the surrounding liquid fades toward a pale turquoise, signaling the solution is being emptied faster. What shape will this metal forest take? The dendrites now sharpen into needle-like tips, each catching the bench's light and flashing like microscopic mirrors. Tiny sparks of reflected glare dance across every point, making the orange metal sparkle like frost on a cold morning. It feels as if the garden has turned into a field of crystal needles. Will they reach up? The liquid has turned nearly transparent. The once deep blue almost vanished, leaving only a faint green film on the glass walls. The copper structure now stretches half the beaker's height, a bright orange tree rising from what was once a clear solution. The question lingers, how much longer can it grow? Will it stop? The copper stalk now reaches for the beaker's lip, its tip hovering just a centimeter below the rim. Its vibrant orange silhouette throws a bold shadow onto the black countertop, a reminder of how far the metal garden has climbed. Meanwhile, the power supply hums steadily, keeping the growth alive. Can it break the surface? Beside the beaker, a small aluminum paperclip sits expectantly. When the copper tip gently brushes it, a faint spark flickers in the dim light, a silent sign that the two metals have touched. It's a delicate moment, like a shy bee landing on a flower, hinting at new possibilities. What will happen next? The copper dendrite now swallows the paperclip, winding orange metal around it until the original shape disappears beneath the growth. The once recognizable clip is hidden, overtaken by a self-sustaining cascade of copper that seems to feed on itself. This dramatic takeover raises the stakes of our garden. Will it keep climbing higher? The copper branch finally pierces the beaker's lip, letting a smooth orange pendant dangle over the bench edge. Light catches its polished surface, spilling a soft halo of gleam across the surroundings. It feels like a newly blossomed flower, a triumph of metal blooming beyond its glass garden. What final shape will it take? The final sculpture now resembles a miniature tree, its many branches stretching both inside and outside the beaker, a tangled network of orange veins. The liquid is almost colorless, a clear sign that most copper ions have migrated into the structure. It's a silent testament to material migration. How will we test its strength? We cut the power, and the copper tree stays perfectly rigid, refusing to collapse as one might expect. A casual tap on its base with a fingertip produces only a faint vibration. No wobble, no break. The structure seems as solid as stone, despite its recent birth. We'll hold. The beaker now rests on a precise scale, the needle shifting ever so slightly upward. The total mass has risen precisely by the amount of copper missing from the anode, a quiet confirmation that matter hasn't vanished, just migrated. It's a real-world proof of conservation in action. What can we do with it now? The copper tree now doubles as a sturdy electrode. When we attach a tiny LED between its tip and the original anode, the light bursts on bright, proving the newly grown metal conducts electricity just as well as the original piece. It's a vivid display of function born from growth. What other shapes could grow? Back on the bench, the orange anode shows erosion. The copper tree gleams, and the once deep solution is now a faint whisper of color. The mystery resolves. The metal didn't appear from thin air. It migrated atom by atom from the dissolving anode, a lesson in electrodeposition. Remember, every impossible growth starts with a single seed.